Practice quiz number 2 from sections 3.3 and 3.4. You'll want calculators out for this. It's your quiz. So I'm going to make you guys do all the work. It is not on big ideas. The only way that you can get the points for this is by turning in the paper copy or sending me an email of the paper copy.
So our answer
Make sure you have your name on it. Claire?
How many questions?
10.
So our answer for this has to be in degrees.
That's correct. Yes. Quiz. Caleb, it says these questions I've not only answered today, but if you look in your agenda book, you should have written down already. Okay. We do have a quiz on Monday over these 2 sections. That's why we're doing the practice quiz today. Caleb, it says find the sum of the interior angle measures of this polygon. Can you tell me what kind of polygon this is? It is a hexagon. It has 6 sides. That's called a hexagon. You don't need to know the name for this shape. You only need to know how many sides it has. Because it has 6 sides, Caleb, how many triangles will be inside of it? 4. Yeah. So remember, if you want to visualize the number of triangles, pick one of the vertices, any one of them, and you can draw the triangles inside of it by connecting all the non-adjacent vertices to that one single vertex you chose. Of course, the 2 that are already adjacent to the left and to the right are already connected. So that's going to make 1, 2, 3, 4 triangles. But we have a faster way of doing it. As Caleb said, there's always going to be 2 less triangles than the number of sides it has, because 2 of the vertices are already connected. This one here and that one right there. So if you take the number of sides it has and subtract away 2, that'll give you the number of triangles it has. Caleb, once I have that number 4, what do I do? Yeah, every triangle has 180 degrees. So Caleb, how many degrees will this hexagon have? And then we're going to make sure we label that with a degree symbol, because every time you're finding something in degrees, you want to make sure you have it labeled properly. Everyone see how we did that? You're not going to have to draw the triangles on the quiz tomorrow or Monday, as long as you know this. If you know that you just need the number of sides minus 2, times that by 180, you don't have to draw triangles inside. You could just use that. Ashton? Oh, maybe. Levi?
On the quiz Monday, will you have to, you ever say that a polygon not give us a visual? Will we ever
Like I said, this how many degrees are in an octagon? I just had that one sentence there with no picture. No, because you didn't have any homework questions like that. I mean, it could be a bonus question like that. But since the 10 questions on the quiz come from your homework, if you didn't see any like that in your homework, you won't see any like that on your quiz. Number 2. Now, this is what we call a concave polygon, because it's actually indented, right? It doesn't have a bunch of angles that kind of wrap around and form a round edge, not round edge, but kind of a round shape where you can go around. This one's actually going to go into it. That actually does not affect our theorem of finding the number of sides and subtracting 2, though. So Ashton, what kind of shape is this? What do we call it? A hexagon, so it has 6 sides?
No.
How many sides does it have? 5. What do we call a 5-sided shape? Pentagon.
I said hexagon because I thought it had 6, but it doesn't.
It has 5 sides, so we can take a shortcut here without having to draw the number of triangles. We can subtract 2, and that gives us 3. There are 3 triangles inside this shape. Ashton, each triangle is 180 degrees. So how many degrees are there in a pentagon?
540.
540. Now, you guys have done enough of these by now that you start to memorize some of these. Show me the work anyways, even if you already have it memorized. Even if you already knew that pentagons had 540 degrees, I still want to see that work. Now, unlike the last problem, we're not done with this one, because it doesn't just ask how many degrees are there if you add up the interior angles. It wants to know what x is. So now I have to set up some sort of equation. And yes, I must set up an equation. Olivia, what's that equation going to be?
and then I simplify.
That's fine.
So you get 108 minus.
Wait, no, it's not
It
right.
should be 270.
Should be good. Right, it's plus 90 in the corner.
Do we have, yeah, did we count this? Okay. So if we add 74 and 106, we get 180. So if we add 90 onto that, it should be 270. Okay. So we have added our like terms together. And if you want to jump right to the equation where your like terms are already added together, that's fine by me. I just need to see, I mean, you can't go any farther than this. Don't go any farther and start moving stuff around from one side to the other by doing addition and subtraction from one side to the other. Just combine your like terms. That's it. Oh, that's as far as I'm going to let you go on that first step. Okay. Oh, we have a fire drill.
It's real.
Did you remember that they told you we had a fire drill?
Yeah.
Wait, so with the first shape we did, would that be called a convex? A convex?
All right, quiet. Quiet. Mascot, please. Thank you. Max, you were answering this question apparently. So what do I do to solve this equation?
So 540 is equal to 270 plus 9x. You minus 270 both sides.
Okay.
And then you get 270.
Okay.
9x is equal to 270. Then you divide by 9. X is equal to 30.
Awesome. Does it ask you to find the measure of an angle?
No.
So I can just leave it as x equals 30 as my answer. I don't need a degree symbol. I won't take off points if you put the degree symbol on there. But I don't need to find out what this x8 or 8 times x degree angle is. I don't need to do any of that extra stuff. It just had to find the value of x, and we've done that. Yeah. So number 2, the only thing that could throw you off in number 2 is if you forget that right angle there, which is a common mistake. I see that a lot actually. Let's move on to number 3. You guys good?
Yes, sir.
Number 3 says find the measure. Ooh, this is a degree question then. Of each interior angle in this regular polygon. Round your answer to the nearest tenth if necessary. Who can explain to me what a regular polygon is? Dylan?
Is it a polygon that each angle is the same?
That is correct. A polygon in which each interior angle and exterior angle, actually, we learned that, is the exact, well, yeah, is congruent is the actual phrase we use, is congruent. And each of the sides on the polygon are also congruent. So everything's the same. So how many sides does this polygon have, Cooper?
It's got 8.
Okay, what do we call an 8-sided polygon? An octagon. It's got 8 sides. So to find out what the total number of degrees is going to have, take 8 minus 2, 6, and times by 180. 6 times 180 will give us the number of degrees in an octagon. Yes, Ashton.
1080.
1080 degrees. Okay, that's not our answer. That would be the answer to question number 1, where it was just asking what's the sum of the interior angles. It wants to know what each of these angles are. Now, Dylan's already told us every single angle in this regular polygon, regular being a very important word here, every angle is the same. So if all 8 angles are the same, Caitlin, what do I do? Yeah, just divide it by 8. Let Caitlin do that. Don't shout out answers, Max. Caitlin, what do you get?
You get 135.
And how do I label it?
Degree.
Degrees. So I don't need to round to the nearest tenth on this one then. We good?
Yeah.
Claire?
On the quizzes for big ideas,
Yes.
like that they would make them use those, do they also just take homework questions and put them on the quiz?
I wish.
That's one
Yeah,
of
they're all
them.
different. I wish that I could pick and choose and say, I like make your own quiz from big ideas.
Oh,
Be
that's
awesome.
different.
Graded already. I could look at your work afterwards, but yeah, they don't let you do that. So. AJ, would you like to do this one? Okay, number 4. Now, AJ, what's different about number 4 that we didn't see in number 2? Yes, still solving for x, but these are exterior angles.
Exterior angles.
And what? Sorry, were you saying something, AJ? Oh, okay. So do I find out how many sides there are, subtract 2 and times by 180? No, Devin, do you remember what all the exterior angles would add up to?
360.
Yes, all of the exterior angles add up to 360. That's true for any polygon, not just this pentagon. So, Devin, create an equation here.
360 equals 6x plus 138.
Okay. Now he's went ahead and combined all of his x's. We're setting equal to 360. While you guys work on solving that, let me explain again why it's always 360. The more sides your polygon has, the more exterior angles it's going to have. But as the number of sides increases, the number of these exterior angles actually decrease in size, because if the number of sides increases, the number of the angles, some of the interior angles gets larger because the angles get bigger. And if the interior angles get bigger, the exterior angles get smaller.
Plus, if the exterior angles got bigger, if the shape got bigger, if the angles got more, then it wouldn't be.
Well, that's true. The interior angles get larger, but the exterior angles therefore get smaller. And so the distance around something has always been 360 degrees. If I'm going around it, not inside, but around to the outside, you'll get 360. Okay. So who have I not heard from? Camden. Camden, help me solve this.
So you subtract 138 from both sides,
Okay.
and then you get 6x equals 222. That by you divide both sides by 6, and you get x equals 37.
37, okay. And just finding the value of x, so I don't need to write any degrees or find out what the 2x degree angle is or anything like that. Number 5. Number 5 says tell whether these triangles are similar. And so we're going to have to show some sort of work here to figure this out. So
Or you wouldn't have to if they had two of the same angle.
that's true. That's true. We would just mention that. So do you see any angles that are congruent?
Yes.
Which ones?
48, 48, 48, 48.
So you
Okay.
have to solve for one triangle, though, right?
Okay, so we have one
Yes.
pair. We have one pair of corresponding angles, the 48-degree angles. If I can prove that there's two pairs of corresponding angles that are congruent, then I'm done because all three will be congruent. Now, I don't see a 23-degree angle listed, but just because it's not listed doesn't mean it's not there. We learned that the hard way yesterday in the notes when everyone said this is not similar and we found out, oh, whoops, it was. Okay, so we actually are going to go ahead and subtract 180 minus 111 and 148 makes 159. And what's 180 minus 159? 21. Okay, now we have enough information to say there will not be two sets of congruent angles, because the only way this would have worked is if this would have said 23. Then I would have had that being 23, this would have matched up, and that means this would have been 48, they would have matched up. Okay? There is no way that I can have three sets of congruent angles anymore, because that's certainly not 21 degrees. So the only chance it had was if that one was, and it does not. So the answer here is no, they are not similar.
The opposite angle would be 1.
Yes, it'd be 2 degrees more than 111. Mhm. Yep, they are not similar. Could you get the door for me, George? Only had one pair of corresponding congruent sides. Number 6, tell whether these triangles are similar. So I see that they both have a 90-degree angle. I don't see a 39-degree angle on the other triangle or a 51-degree angle on the first triangle, but it doesn't mean it's not there. We have to add to make sure. So let's take 180. I'm looking at the triangle on the right side right now, just because I have more space over here. We're going to subtract 90 and 51. 90 and 51 makes 141. So what's 180 minus 141, Max? 39. So there is a 39-degree angle over here. And if I can prove that there's two sets, then I know there will be three sets. So I know this has to be 51 degrees just by default. Otherwise, it wouldn't add up to 180. So these are similar. Remember, to be similar doesn't mean the sides have to be the same. It just means the angles have to be the same. The sides are going to be proportional if the angles are the same. So same size, different shape. No, I said that wrong. Same shape, different size.
So it fools you because you have to flip that triangle on its side and then backwards.
You know what really fools you is the fact that at first glance, these triangles don't even look like they're the same shape.
Yeah, they don't because you have to flip
Because
that
it's
one on its side.
flipped.
and flip it that way.
No, you can't make it look like the same shape.
It could be flipped,
You
but
You
flip
don't
it and then
make
you
it
turn
longer.
but there should be one side that's clearly longer than the other side, right? I don't see that over here, and I'm guessing the reason, two reasons that could be. Number one, we learned yesterday when I got the protractor out that not every shape they draw is accurate. Okay.
Yeah.
Number two, maybe they were trying to mislead you and make you have to do the math to see if it's
Get
similar.
your question wrong. That's just proof. That's that. Come on.
Number 7, right? Yeah, number 7. It says find the value of X. Now, the questions you had on your homework asked you to prove that these were similar first, because this only works. I can only find out what X is if these are similar. And the way that we know they're similar is by having 2 sets of corresponding angles. Well, there's one set. Where's my second set, Harrison?
The 2 things that connect the
Yes, I think you were the one that said that yesterday, right?
Yeah, he did.
Because vertical angles are congruent, we know that those two will be the same. Therefore, these angles, whatever they are, will have to be the same because they'll have to add to 180. So they'll have to be the same exact measure. So they are similar, and knowing that they're similar, we can go ahead and find X by setting up a proportion. Someone new, Jocelyn. Jocelyn, what's one proportion? Let me get all these red marks out of your way. What's one proportion we could write? I say one because there's multiple ones to solve for the value of X. Maybe I should have left these here. And I should have left these there. Can you give me a proportion? These are kind of difficult because they've been reflected. There's really what's kind of going reflected and also rotated and dilated, right? It has to be dilated to proportional. Jocelyn, tell me the side of the big triangle that's between the right angle and the 2 hash marked angle. 7, okay. Do the same thing on the little triangle. What side's between the right angle and the 2 hash marked angle? The X. So I did that sometimes even just drawing your marks and saying, okay, I know these are the same, I know these are the same. It allows you to identify markers on the triangle, so you know that you're using corresponding sides. Okay, let's go back. Since we did the big triangle first, we got to go back to the big triangle again. What's the, well, this 12, we have to use 12, right? And it's between the 1 mark and the 2 mark. So on the other triangle, Jocelyn, what's
Antonio Anderson,
what's between the 1 mark and the 2 mark? 3.
Andrea De La Garza, Julia Barnett, Carson Dewey. Please come to the office.
Don't say anything.
Hannah Hoover, please come to the office. And Aston Boley, please come to the office.
Okay, so it's not the only proportion you could write, but however you write it, the 12 and X should be diagonal for each other. So let's go ahead and multiply those. Haven't heard from Jace yet. Jace, what's 12 times X? And what's 7 times 3? And what's 21 divided by 12? 1.75. So then the answer would be no, you don't have to write it in fractional form.
Yeah.
You could write 1 3/4.
Yeah, but I wouldn't want to do that because you already planted to say that.
Oh, this one requires a label because it's feet, so make sure we label that. If you have a question like this on your test Monday, I will also want to label, and that'd be clearly written in the instructions that you need to label. Okay, 1.75 feet. Bonus question. How many inches is that? Dylan?
That is 20.
Close.
21 inches.
21.
I
So-
got it right.
1 full foot would be 12 inches, and then 3/4 of 12 is 9 inches.
Oh.
So 21 and 9. Or sorry, what did I say? 12 and 9 makes 20. I think I said 21 and 9.
12x equals
Or you could just do 4 times 3.
What?
It says 12x equals 21 before you simplify x equals 1.75.
Oh, very true. You're right. Yeah, because we divided by 12. If you undivide by 12, which is the number of inches in a foot, just happens to be the number of inches in a foot.
That's
You're back to 21.
weird.
That's a coincidence.
It is a coincidence. Number 8, the value in degrees of each of the interior angles of a regular n-gon is represented by x. Write an inequality that describes the minimum value of x. Okay, so x is representing what here? The degrees of each of the interior angles of a regular n-gon. Okay. So what happens to the interior angles as you increase the number of sides?
It gets smaller.
They don't. The exterior angles do.
Oh, they get bigger.
They do. Okay, they do. So as you increase the number of sides, those angles become larger, larger, and larger to compensate for the fact that you've got to go all the way around that shape now. So as you increase the number of sides, the interior angles are going to get bigger. But x represents each of the interior angles on a shape where we want the minimum value. So what's the minimum number of sides that a polygon can have?
3.
3. The smallest polygon, the smallest number of sides you can have on a polygon is 3, which is a triangle. Okay. We mentioned this yesterday, or no, I guess it was Wednesday. What's a regular triangle look like?
A triangle.
Equal the same size.
Yes, it's equilateral and equiangular. And if I take 180 degrees, which is what a triangle has, and divide it 3 ways, how much is each of the interior angles going to be?
Gotta be 60.
60. So x, the smallest it can be, is 60. Because x represents each of the interior angles, as it says right there, each of the interior angles. Okay. What does a regular quadrilateral look like?
4 is a square.
That's a square. And if I divide 360 by 4, because a quadrilateral has 360 degrees, I get 90. And so as you increase the number of sides, the interior angles get bigger. Therefore, the exterior angles, as we saw in problem 4, get smaller. And they'll always add to 360 for the exterior angles.
We're flying.
Number 9, a swimming pool is in the shape of a regular decagon. How many sides does decagon have? 10? Okay. But it says it's regular, so we're going to have to use that word because it's going to help us with this problem. One edge of the pool is directly against the outside wall of the house. You can see that angle that's being formed. They're calling that angle X right there. It wants us to find the measure of angle X between the house and the pool. Now, angle X is an exterior angle. So it doesn't matter how many sides it has. All the exterior angles will add up to 360. Now, for a decagon, more specifically for a regular decagon, which regular means all the interior angles are the same, so all the exterior angles will also be the same. For a decagon, there's not only 10 interior angles that are the same, but there's 10 exterior angles. So that 360 degrees has to get split 10 equal ways because it's regular.
That's weird. I just said.
So Levi, what do you get when you divide 360 by 10?
36.
36.
I literally said it looks like 35 degrees.
Wouldn't it be degrees because it says measure?
It does say measure. You're correct. I almost labeled it.
Doesn't have a degree.
You're right. They didn't do a good job. If they wanted you to just solve for X, they should have said find the value of X like they've said every other time. But if it says find the measure, we need to be labeling it in degrees. So that should be 36 degrees.
It's 36.
Come on, everyone knows it's 36. Number 10, you want to know the total width of a 4-lane highway. So you take measurements, because you don't want to get hit, I guess.
Yeah.
So you take measurements on your side of the highway and make the drawing shown. All your measurements came in the safe zone without getting hit. Okay. Now, this only works if you use 2 similar triangles. And so what they want us to do for part A is to figure out which triangles are similar. Now, we know the triangles are similar because, as Harrison's already pointed out, vertical angles will be congruent. Right angles are the same. So you got 2 pairs of corresponding sides that are equal. So both these triangles will be similar. They almost look like they're the same size actually, but that doesn't always be the case. Similar doesn't mean they're the same size. So I know they're similar, but what I have to do here is I have to figure out what the similarity statement is. Remember we did congruent statements on our last test. Similarity statements, they could have used those single squiggly line which represents similar to, they just spelled the word out here. But I need to know which of these is true by looking at making sure the corresponding angles match up. Now, I know for certain that E and A match up. I also know for certain that ECD and ACB match up. So C is going to match with C, right? That's the same vertex. And I know B has to match with D. So which of those following statements has what I'm looking for? Caroline. B. A, B, C. So A to B to C is similar to E. That's good. E and A have to match up. To D, that's good. D and B had to match up. To C, C and C had to match up. Obviously, it's the same vertex. Okay, so good. So option B. I want you to actually, instead of writing option B, I want you to write that out. Triangle ABC is similar to, you can use the abbreviation, squiggly line, triangle EDC. It's not the only way you could write it, but it's the only one that they listed that was correct. Part B now wants to know what that X is. That obviously they're going to have us find X. So let me, again, this might help to have some visual markers we can identify. Those two angles are the same. And those two angles are the same. Now, if I start my proportion with the number 90, just the corresponding ones are.
Oh, okay. Well, because E and A are the same too.
Yes, they're corresponding.
Oh,
They're the same.
yeah, I just needed a circle or whatever.
No, because they already had a right angle mark.
Oh,
So I just left that right angle mark there. Now, if I start with 90 as my first measurement, what number could I go with for my second measurement? Or what letter I should say, could be a variable too. It's gotta be X, yeah. Because 90 on the left side triangle was between D and E, which D and E, now I have to use B and C. Oh, wait on a second, that was the wrong one. D and E has to be E and D, A and B, thank you. I keep thinking for whatever reason I was up here. Okay. Or if you have the visual markers between the right angle and the two tick angle. Right angle, two tick angle. All right, Colin, back to the left side triangle. What's the number I have to go with for my on the other side, the top? And what number has to go on bottom? 30.
So it could
20.
be 30 over 25 or no?
It could be 30 over 25, only if you did X over 90.
Oh, okay, never mind. I didn't realize that. I didn't know that was 6 times.
So we're going to cross multiply. Olivia Sefton, what do you get when you multiply 90 times 30? 2,700, okay. Can you divide that by 25 and tell me how far it'd be across the 4-lane highway? 108 what? Feet. All right, sound good?
Yep.
All right. So part B was 108 feet. And we have finished the practice quiz. Claire,
You know, if this is actually how far it is across the board.
doubtful. Probably just for this one.
Yeah.
And yeah, sometimes there's big wide medians between those 4-lane highways, especially on the interstates where there's parts if you go travel south or part of the interstate goes this way and the oncoming lane is like there's like almost like a forest in between it for a little bit before they
Oh,
converge
that's
down.
when I'm on
So.
Florida, I always see that.
Yeah, I know what you're talking about.
Yeah.
I used to live there,
Yeah.
so.
When I-
And it's in the median, yeah.
Yeah.
Yeah, I just camp out there in the woods.
Oh, yeah.
When I was
Yeah.
driving
That road is so
When I was
long.
driving to North Carolina, there would be
Hi.
rocks sticking out from the wall.
Okay, I need your papers. If you're quarantined, you need to email me your papers. You guys, don't put them in the tray. Don't put them in the tray. Don't put them in the tray.
Don't put 'em in
Set
the
them right
tray.
here.
Yeah,
Thank
set them
you.
right there. You have to reach your hand through it.
No, that's illegal. That's illegal. I know for a fact.